Okay, here's a pretty lengthy lesson on quadratic modeling. Sorry it's so long, but it's kind of like something that's maybe a bit more new for you compared with linear modeling. So we just want to make sure you've kind of really got the right idea behind it all. So quadratic modeling, you're probably already familiar with the quadratic model. It's in the form of y equals ax squared plus bx plus c. Looks similar to a, what am I trying to say? Similar to a quadratic sequence was what I was trying to get at. So same thing as linear to some extent is the C represents the y-intercept. Because at the y-intercept, if you just sub in x is 0, you end up just getting the value of C. But A and B don't tell you the gradient, because on a quadratic models kind of are like this or they're like that. You don't have a constant gradient with quadratic models. You have, because it's not a straight line, you have kind of a changing gradient. So notice kind of at parts like here, the gradient is quite steep, whereas parts like here, the gradient is quite flat, like that. And at the vertex, the gradient is technically actually 0, because it's a horizontal line at that point. Anyway, so A and B just tells you, we call that the dilation factor. It tells you, like, you know, first of all, it tells you is it facing us opening upwards or is it opening downwards. So if A is positive, it's opening upwards like this one. If A is negative, it's opening downwards like this one. You might hear me refer to it as a frowny or a smiley. Positives, they open upwards. A is positive. If A is negative, the graph opens downwards, so that's a frowny. Also, by dilation factor, it tells you if it widens or not. So the general setting is y equals x squared. If you make it y equals 3x squared, the graph becomes narrower. If you made it y equals 1/3 x squared, the graph would become wider. That's the general gist of that. B doesn't necessarily tell you anything kind of useful in terms of the graph. So in the space below, draw a sketch of this type of function and write out its general equation. And now see page 3 or 4 if you forgot, but I've also happened to have pasted it in your title. Then you'll be asked, what are some of the features of this type of function? And I'll put in a diagram to help you. So let's just practice doing a little sketch of one. Draw a very vague coordinate plane if you want. Your x-axis, your y-axis. Just getting used to the idea that functions have, we deal with x-axes and y-axes and what we call a coordinate plane. For a sketch of this type of function, so I'll just do a basic one, kind of like this. It's fine, you could have done one like this instead. You could have done one like this instead. You could have done one like this instead. Could have done one like that instead. Could have done one like this instead. So I'm just showing you they're very vague. So I'll do one like that, for example. I'm going on infinitely. Draw a sketch of this type of function, write out its general equation. So general equation is y equals ax squared plus bx plus c. That's general equation for a quadratic. If you want to draw an example of a second one where it's kind of opening downwards, feel free to do that too. So what are some features of this type of function? The below diagram might help. So you might have realized from there it's symmetrical. And has an axis of symmetry. So an axis of symmetry, which they've kind of drawn. See the orange dotted line? The orange dotted line is the axis of symmetry. So just sort of pointing it out. It's not an asymptote. This is just an axis of symmetry. It's just an invisible line. It's not part of the function. It's just pointing out that either side of this axis of symmetry, the function is actually the blue thing. It's symmetrical about the axis of symmetry. So the axis of symmetry is just to point out the fact that the graph, which is the blue one, happens to have an axis of symmetry. Now generally has a y-intercept, at y equals c. It's another attribute. It's possible to have 2 x intercepts, so it could have 2, 1, or no x intercepts. Same thing like when you factor a quadratic, when you factor and solve a quadratic, you can get two solutions, one solution or no solution. And that's because the results of factoring a quadratic tell you what the thing is, what the x-intercepts are. So I just drew an example of a quadratic that has no x-intercepts, and I'm about to draw an example of a quadratic that has one x-intercept. See, it just touches the x-axis. The one that is to the left is an example of one that has two x-intercepts, one here and one here. So two solutions, sometimes they call them zeros. So another name for that is two x-intercept solutions. On the TI-Inspire, they call them zeros. So because at x equals 0 is when you, at y equals 0, sorry, is when you get these x-intercepts. Something else to do with these thingies, they have a vertex. They have a vertex, not two turning points, they just have one turning point. They have a vertex, which coincides to some extent with the axis of symmetry. So they have a vertex which coincides with the axis of symmetry, meaning that the x-coordinate of the vertex is the same as the axis of symmetry. What would be the axis of symmetry equation in this case? It would be probably x equals 1. So the vertex, so this example has an axis of symmetry at x equals 1. So the vertex for this one would be something like 1, x equals 1, and then y equals probably, let's see, 1, 2, 3, negative 4. So this vertex, is it a maximum or is it a minimum? This one is a minimum. So this is a vertex. This one is a minimum because it's the bottom of the graph. If it was like this, there would be a maximum because the vertex is at the top of the graph. So this one is a minimum. Anything else? If you can think of anything. Oh, domain and range. So domain is easy. There's just XER because it goes out infinitely horizontally. Whereas a range is restricted according to the vertex. So according to the y coordinate of the vertex. Coordinate of the vertex. So in this case, you would say this example has a range of y is greater than or equal to the y coordinate of the vertex because it's all above. So see, the graph doesn't live kind of down here at all. It only lives above y equals negative 4, doesn't it? The blue kind of function doesn't even exist down below that. Whereas it exists infinitely in the horizontal direction because it's spreading out infinitely and horizontally. It is a function according to the vertical line test. Is a function as a vertical line could not cut more than once. Not cut more than once. Or cross the function more than once. That'll do for now. That's okay for now. Let's just move on. Right, the features of a quadratic function. So some of this might be a bit repetitive, just so to make sure you get the hang of it. The general form of a quadratic equation is ax squared plus bx plus c. The y-intercept of the graph is always the value of this thing here. This tells you the y-intercept. So remember at the y-intercept, x equals 0. If you sub in x equals 0, this part cancels and that part cancels. So that's why the y-intercept is always just the value of c. The equation for finding the axis of symmetry is, now you might not realize this, but as you can see from the previous, a quick way to do it is from the previous example, if you just take the average of the two x-intercepts, then you'll get the coordinate of the axis of symmetry, because the axis of symmetry is right in between the two x-intercepts. So this x-intercept is -1, this one on the right is 3, -1 plus 3 is 2, 2 divided by 2 is 1. That's a shortcut for finding it. Oh dear. I just entered a thing, an extra page by mistake. Right, so there is another one. So you could just take the average of the two x-intercepts. That's a quick way to do it. There's another one which you could use the formula -b over 2a. So this might be useful. You might have learnt this before, you might not have. And the b and the a come from the general form of the quadratic equation above, like ax squared plus bx plus c. So that's another way. If I typed in, if I knew the formula for the quadratic, I could sub in -b divided by 2 times the a, and I would get the coordinate, the axis of symmetry equation. So it is an equation, so you shouldn't just write -b over 2a. You need to write x equals -b over 2a. The something is a turning point of the graph. What is that word? It is the vertex. The plural of vertex is vertices. The vertex is the turning point of the graph. It can be a mat or a meet. It's a maximum, if it's kind of like graphs going like that, or a minimum, if the graph is kind of going like that. You find the coordinate of the vertex by graphing the function on the TI Inspire and pressing Menu, Analyze Graph, and then you can select maximum or minimum. You can also do it by hand by finding the axis of symmetry coordinate. So by hand, you could use x equals -b over 2a, because that happens to also tell you the x coordinate of the vertex, and subbing this value into the equation and substituting into the equation to find the y-intercept, the y coordinate. That's how you would do it by hand, what I've just written there. To do it on the graph, you would graph it, graph the quadratic, because imagine you're told the equation, press Menu, Analyze Graph, either select maximum or minimum, depending on whether the graph has a maximum or a minimum, and then it will give you the coordinate. There can be 2, 1, or no x-intercepts on a quadratic function, as I mentioned on the previous page. To find the intercepts, graph the quadratic on the TI Inspire and select Menu, Analyze Graph, and 0, because 0 is the same name for x-intercepts. Or just solve the quadratic, or by hand by solving the quadratic using the null factor rule. Using the null by setting it equal to 0, null factor law, meaning setting the quadratic equal to 0. You could solve by factoring, or you could solve by quadratic formula, complete the square, whatever. That's how you would do it by hand. That's how you find the x-intercepts. So a lot of graphing using the TI Inspire could happen here. On the diagrams below, label the vertex. I just want you to label the vertex. Here it is. Its coordinates are, is it 1, which kind of shaky on mine. I'm in trouble sort of seeing the coordinates properly. I'm assuming it's going up by 1s. 1 and 3. X coordinate is 1, the y coordinate is 3, assuming that that's what the scale goes up by. I can't see it very well on this board because it's a bit blurry. Here's the vertex on this one. It would be at 1 and probably -4. It's a bit rough. This one, it is minimum because it's at the bottom. Minimum vertex. This one, would you agree, is a maximum vertex? So if you wanted to know the axis of symmetry, it's x equals 1 for the first one. It would be also x equals 1 for the second one. It happens to be the same as the x coordinate of the vertex. What about this one here? Is our vertex, it's a maximum, and it's at 1. Pretty boring because we're all at 1. 1 and 3. Just like the other one. Maximum vertex. And this one, just down the bottom. This is exactly the same. Have I just basically put the same thing? Oh, we weren't asked for that. We're asking for the axis of symmetry. It is the same graphs, but they're asking for different things. So here we want the axis of symmetry. Just a dot, dot, dot line. Cut through the center. And we already know that the vertex is x equals 1 and 3. So the equation of the axis of symmetry is just x equals 1, because it's a vertical line. Axis of symmetry on this one, cut through the center, just draw it in there, and it's x equals 1 as well. Pretty boring. The other way is find the average of the two x-intercepts, or if you knew the equation, x equals negative b over 2a, if you know the formula for the quadratic. Now label the y-intercept. Y-intercept is just here, so it's at 2. The y-intercept for this one is about here. Seems to be at negative 3, according to my graph. Easy enough. On the diagrams below, the same ones, label the x-intercepts. X-intercepts, oops, skip ahead. X-intercepts are here and here. These are a bit rough, these ones, so maybe let's say negative 0.75 for that one. And maybe this one is 2.75, 2.7, whatever you think it is. It's a bit rough. Here's the two x-intercepts on this one. I think this one roughly is at negative 1, and this one is at positive 2. Is it positive 2? I don't know, it's a really badly drawn graph. Maybe it's 3, let's say 3. Because again on my board it looks a bit funny. Let's see, two x-intercepts. Find the y-intercepts for the following. That's easy enough. Here's a y-intercept here. It's at negative 3. Y-intercept here is at 0. You could just write y equals 0. Y equals negative 3. Super easy. You might want to try these ones by yourself and just check your answers with what I've got. So we seem to have 1 here. X-intercepts, I want this one here. X equals negative 1. X equals 3. For this one, that one, x equals negative 4, x equals 0. So we've still got 1 and 0. Two x-intercepts in those cases. Find the equation of the axis of symmetry for the following. So it's going through here. Let's draw it in. We've got x equals 1. Pretty boring. Turned out to be x equals 1 again. This one's a bit more interesting. Kind of through here. It's slightly different this time. It's at x equals negative 2. Because notice it has to be an equation. Don't just write 1 or negative 2, because it has to be an equation, or else I'll mark it wrong for the axis of symmetry. Find the coordinate of the vertex for the following. So here's a little vertex. Did you get 1, negative 4? Remember x before y. That's a minimum. Here's a maximum. And did you get negative 2 and 4 for this one? Notice that the x-coordinate of the vertex is the same as the value for the equation of the axis of symmetry. How to find the features if you're just given the equation and not the graph. So imagine you weren't given the graph on the last examples, I gave you all the lovely graphs. What if we were just given the equation? Remember the general form of the equation is ax squared plus bx plus c. So obviously, you realise you can always find the y-intercept just by looking at the c. The y-intercept, as we said, is always just the value of c. The equation for finding the axis of symmetry, I'd suggest use x equals negative b over 2a, because if you're given the equation above, you just sub in negative b and 2a over 2a. That's easy to do. Just reminding us again that the vertex is the turning point of the graph. It can be a maximum. As I said, I'm doing a bit of overkill here, but I really want you to make sure you know this, or a minimum. You can find the coordinates of the vertex by graphing the function on the PI spire and pressing menu, analyze graph, and then maximum, choosing either a maximum or a minimum, because you would graph it to begin with, and you could decide by looking at the graph, does it have a maximum or a minimum? So, and you can do it all by hand. Use x equals negative b over 2a to find the x coordinate, because it's the same thing, and then sub into the equation to find the y coordinate. To find the y coordinate. There can be 2, 1 or no x-intercepts on a quadratic function. To find the x-intercepts, graph the quadratic on the TI Inspire, press menu, analyze graph, and 0. Because x-intercepts I call zeros. By hand, solve the quadratic using the null factor law. Using the null factor law just means set the quadratic equal to 0 and then solve it any way you want. You can either factor it, or you could use quadratic formula, or you could use complete the square. Find the y-intercept for the following quadratic functions. Recall the y-intercept is always the value of, in case you didn't get it before, it's c. Lovely. So here I'm just giving you equations. So the value of c, the y-intercept, will be, so remember the y-intercept? I should write this. At the y-intercept, x is 0. Just reminding us of y. At the y-intercept, x equals 0. So if you sub in 0 and 0 here, you're just going to end up getting an answer of y equals 1. So the y-intercept is at 0, 1, if you need to write it as a coordinate. If you sub in 0 and 0 here, they'll cancel out, and you'll just get y equals -5. That's the y-intercept, or 0, -5. Sub in 0 and 0 here, you get y equals +3. And sub in 0 and 0 here, you'll just get y equals 0. Sub in 0 here, you'll get y equals -11. Interesting, sub in 0 and 0 here, you'll get 0 minus 4, 0 plus 1, which equals -4 times 1. So y equals -4. So that's a way you could find it. You sub in x equals 0. Or you could FOIL the quadratic equation to begin with, and then you'll end up seeing that the y-intercept ends up just being -4. And you expand and collect like terms. Now you're asked to find the x-intercepts for the following quadratic functions. Remember, there can be 2, 1 or no x-intercepts on a quadratic function. To find the x-intercepts, we set the quadratic equation equal to 0 using the null factor law, and then solve by factoring first or using the quadratic formula, or complete the square if you want to write that in. Alternatively, graph the quadratic on the TI Inspire and press menu, analyze graph, and zeros. Okay, so this is an example of one where we could use a quadratic formula. You could try the splitting method as well. If you want to do it by hand, let's try the splitting method to begin with. 3 times 1, so let's see, AC equals 3 times 1, which is 3. What's two numbers that multiply to give 3 and add to give -2? Are there any? Let's see, there's only 3 and 1. So this one doesn't seem to kind of like factor nicely, and there's no common factor. So we could use the quadratic formula, a equals 3, b equals -2, c equals 1. Remember quadratic formula, x equals -b plus or minus square root of b squared minus 4ac over 2a. That's in your formula booklet, don't just guess that. So if we use the quadratic formula, x equals -b, so I'm being really slack, I'll say -b is -2, which is +2, plus or minus -2 squared is +4, b squared minus 4ac, so -4, 3 times 1 is 12, over 2 times a, which is 6. I'm being really slack. So x equals 2 plus or minus square root of -8 over 6. Now let's see, how do I know that there's going to be no x-intercepts? I know there's going to be no x-intercepts because you can't take the square root of a negative number. You'll end up with an imaginary kind of a complex number. So no solutions, no x-intercepts. There's no solutions. let's maybe just quickly open the TI Inspire, practice graphing. Might take ages, sorry. So we're opening the TI Inspire. We're going to practice graphing this for fun because it's just awesome. It'll open up. There we go. It's a little thing. No way. Noise. Cool. On. We want to do a little graph. So we want to graph, where is it again? I've lost it. 3x squared minus 2x plus 1. 3x squared minus 2x plus 1. There's our little graph. Do you agree? There's no x-intercepts. That's pretty special. Okay, so we've just confirmed there's no x-intercepts. So just check our answers that way. Nice and groovy. Yeah. So this one, y equals negative x squared plus 4x minus 5. You could potentially try to use a quadratic formula straight away. If you wanted to factor, I would check this out first. Y equals, divide everything by negative 1. You'll get x squared minus 4x plus 5. Then think, can you just factor what's left in the brackets? Are there two numbers that multiply to give positive 5 and add to give negative 4? No, there's not. Forget it. So a equals negative 1, b equals 4, c equals negative 5. You could just graph it on the calculator if it's a calculator one, or you could start using a bit of quadratic formula. Please don't be slack with your quadratic formula like I am. I'm kind of pushed for time though because I had to go to the rugby classic. Okay, so negative b would be negative 4 plus or minus square root of b squared, so 16, minus 4 ac. So ac is 5, because negative 1 times negative 5 is positive 5. So minus 4ac is just minus 20. Oh, it looks like we might have no solution again over 2a, negative 2, because it looks like we're going to end up with x equals negative 4 plus or minus negative 4. So it looks like we've got no solution again. No x-intercepts. It's boring. There's no solutions. We've got our graphing calculator, so we're going to check that out. We're not going to trust what I've written. Oh, where is it going? Come back, calculator. Let's do a new one. Okay. So we're going to do negative x squared. So use the original function. Don't use the messed around with function. It's always safe to use an original one. Plus 4x minus 5. Oh, yep. If it makes sense, it's opening downwards because it's got a negative a value, whereas this one was opening upwards as it has a positive a.